And I solved this problem for us because we all are pretty clear on how the division process works. When I did 2 divided by 5, I ended up with 4/10, which is a terminating decimal, a decimal that does not repeat. Then when I got to the top of the next page, my problem was 30 divided by 20. So again, I wrote that inside my division box and I divided it and I ended up with 1 5/10, which is also a terminating decimal. Moving on to Mario's problem, I made sure that I paid attention to the fact that Mario ate 1/8 of the pizza and his pet poodle ate 1/3 of the pizza. We're asked to draw a model of the pizza that shows the portion that has been eaten. And I know that most of us like to have our pizzas come nice and round. And when I'm thinking of this, I kind of imagine looking at what this might look like if it was cut into, if I take this one side and cut it into eighths. And I would have this part is what Mario ate. And now I need to think about that pizza only split up into or portioned up into thirds. So I'd start about there and then I would draw my thirds with a different color just so you can see where I'm at. And I'm going to go ahead and this would be the third that the poodle ate. So the region that I'm looking at for this is this region right here. We might be wondering how much that exact, what size that exact portion is that were eaten by Mario and his dog. So what we can do to figure that out is write a numerical expression. We have 1 whole pizza. We can subtract the quantity of 1/3 and 1/8. That would be one way to write our expression. About what percent is left of the pizza? Well, I'm going to go ahead and if I have 24 24ths, because I'm thinking about these two numbers, 3 and 8, and a common denominator that works really well with those two numbers is 24. And if I subtract 1/3 changed into 8 24ths, and subtract 1/8 turned into 3 24ths, that ends up giving me 13 24ths left, which is about 50%. And I'm fine with an estimate. If you went ahead and you made that into a very precise and accurate statement, I'm fine with that. Thank you for going that extra distance. To figure out the next part of this, multiples of 10. Nicole has a machine. It'll produce a number from 1 through 50 when she pushes a button. To find the probability of multiples of 10, I need to think, well, I've got 10, 20, 30, 40, and 50. So my probability to get a multiple of 10 is 1, 2, 3, 4, 5 over 50, or 1 out of 10. Probability that it's not going to be 100. I think that probability is 50 out of 50, or 100%, because we are not going to get 100. It only goes up to 50. The probability that is not a multiple of 4, well, our multiples of 4 are 4, 8, 12, 16, 20, 24, 26, 28, 32, 36, 40, 44, and 48. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 that are multiples of 4. So the probability it is not a multiple of 4 is going to be over here, do 50, subtract 12, just in case we need to double check that. And I've got 38 out of 50. And the probability that it is a one-digit number. One-digit numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the probability it's going to be a one-digit number is 41. Let's do that like we did the others. Probability is not that it is a one-digit number is 41 out of 50. Let's take a look at what we have on our last page, and this is a fun one. I'm going to guess that we have used a calculator, and the first one is terminating. And we can say 2 divided by 5 gives terminating decimal. 7 divided by 45 equals a repeating decimal. Anything we divide by 9 or 99 is going to be repeating. And if you read the math notes, that would tell you some background information for that. And this last one is yes, because 27 divided by 250 equals a terminating decimal. And I'm going to guess that you all did these, you all did those on your calculator. That's what I would have done. All right, we're supposed to be looking at this next one, and these are fun. We're going to see some other diamond problems in the future. I need to look for a pattern, and in this first one, I see that 5 times 2 gives me 10, 5 plus 2 gives me 7. That's not enough to make sure I know the pattern, though. Let's see about this one. 2 times 8 gives me 16, 2 plus 8 gives me 10. So I'm going to go with that as my pattern. So 3 times 4 gives me 12. 3 plus 4 gives me 7. 2 times 3 gives me 6. 2 plus 3 gives me 5. Uh-oh. 12 divided by 2 gives me 6. 6 plus 2 gives me 8. And now I have to think of a number that when I multiply it, I get 28, and when I add it, I get 11. And I'm going to think that it's probably 4 and 7, which works.